How many numbers of at most 3 different digits can be formed using the numbers 0 through 9? Now, sometimes we can't count something all at once. In this case, it says at most 3 different digits, so you could have a 3-digit number, a 2-digit number, or a 1-digit number. And when you can't count something all at once, you use a strategy called cases. The cases strategy basically says count each case separately and then add them up in the end to get the total. So in this case, I have 3 different digits, at most 3 different digits. When we're having a cases question, we always write out what case 1 is going to be. I'm going to start with my 3-digit number, so I'd have 3 decisions. And we have to use 3 different digits, so we're not allowed to repeat. Do we have any restrictions? Can I start with a 0? Yes. No. Right? If I start with a 0, that's a 2-digit number. So this can't be a 0, giving me only 9 choices there. Then I've used up one number. How many choices do I have for my second one? 9 again, because now 0 can get put back in. Now I've used up 2 numbers. 8 choices left. 648. Have we counted everything? No. Case 2, we haven't counted 2-digit numbers. That would have 2 spaces. Do I have any restrictions? Can I start with a 0? Can't start with a 0. 9 choices. 9 choices for 81. Case 3, a 1-digit number. Can I put 0? Yes. Is 0 a number? Yes. Does it have how many digits? 1 digit? 0 digits? I don't know. I'm going to say 10 there. And then once you've got all of your things put together, you just need to add them up. 739. 648 plus 81 plus 10. So anytime you count something in separate cases, you add the cases together to figure out your total. The number one place that we use cases is when there are restrictions and the restrictions overlap. So sometimes you'll get a question that has more than one restriction, as in this one. You want a 3-digit number using 1, 2, 3, 4, and 5, no repetition. It has to be greater than 300 and even. So if I tried to do this all at once, what are my choices for my first digit? Because that's my decision here. The first digit has to be a 3, 4, or a 5. So I'll just write those underneath. And my last digit has to be a 2 or a 4. And if I try to do this all at once, we've learned that restriction question says deal with the restriction first. But I have 2 restrictions. So which one do I do first? Well, let's say I do the first one and say I have 3 choices for my first number. It can be a 3, a 4, or a 5. And then I go to my second restriction, and what number do I put in there? 1? Why 1? It depends if I've used the 4 or not. Can you see that we have the same restriction in both ones? There's a 4. I might have used a 4 in my choice here. Then I need to write a 1. But if I didn't use a 4, then I need to write a 2. And so we have a problem. We don't know what number to write. And you can't write 1.5 because it doesn't work that way. So any time that you have this overlap in your restrictions, you have to solve it with cases. And so you take one of your restrictions and split it up. So I'm going to call case 1. Let's say I take the last restriction, because there's only 2 choices in the last restriction. And in case 1, I'm going to count all the numbers that end in 2. So if I've made that my case, this is going to be a 2. There's only one choice there. How many choices do I have for my first digit now? Well, it could be a 3, a 4, or a 5. There would still be 3 choices for that one. There's no restrictions on the middle space. How many choices do I have left? 3 left. Gives me 9 numbers that will end in a 2. What haven't I counted? Case 2. I haven't counted the numbers that end in a 4. 1 choice. Now for my first digit, how many choices would I have? Only 2, because I can't use the 4, because the 4 is already gone. And the one that has no restrictions on it, how many choices are left? 3 choices left, because you've used up 2 numbers. So remember that even though I have 2 choices, a 3 or a 5 for that first digit, I'm only choosing one of them. The other number gets thrown back into the mix to possibly be in the middle. So this will give me 6 ways. Add them up, and there's 15 ways in total. So when you have 2 restrictions and the restrictions overlap, you have to break it up into cases. If you wanted to, you could do this in 3 cases. You could have taken the first condition and say, I'm going to count all the numbers that start with 3, then all the numbers that start with 4, then all the numbers that start with 5. Add them up, you'll get 15 just the same. If we're using the numbers 1, 2, 3, 4, and 5, and you need them to be greater than 232. They no longer have to be even, but we want to count all the numbers that are greater than 232. Why is there a problem when trying to do it all at once? What numbers could go here? 3, 4, and 5? Is that the only possibilities? And 2. We get a problem here, right? Because if you pick the 2, then you have some issues with what you're allowed to pick and what you're not allowed to pick for the second one. But if you picked a 3, 4, or 5, there'd be no issues whatsoever. Does that make sense? So with these questions where they ask you to write a number greater than, I always start with case 1 and think, what could I start with that would guarantee that it's greater than? That would make no restrictions on my other digits, a 3, a 4, or a 5. So if I started with a 3, a 4, or a 5, I would have 3 choices there, and now it doesn't matter, right? Because I have my numbers in the 300s, the 400s, and 500s. Doesn't matter what digits I put next, my number will be bigger than 232. I've used up one number. How many choices do I have left? 4, because we had the numbers 1, 2, 3, 4, 5. If you pick the 3, you still have 4 numbers left. If you pick the 4, you still have 4 numbers left. If you pick the 5, you still have 4 numbers left. And now you've used up 2 numbers. You would have 3 choices for the last one. There would be 36 numbers in the 300s, 400s, and 500s. Case 2. What haven't we counted? the numbers in the 200s. So we're going to start with a 2. Then what would guarantee that I'll be bigger than 232? 4 or 5. So if I want to start with a 2, then do a 4 or 5, I will count all my numbers in the 240s and the 250s. What does this look like? Again, 3 decisions. Underneath the first space, I'm decided it's going to be a 2. Then under the second space, I'm going to choose a 4 or a 5, which gives me 2 choices. And then the last number has no restrictions because I'm in the 240s and I'm in the 250s. How many numbers are left? 3 numbers are left for 6 choices. Are there any numbers we haven't counted? Yes, there's still some numbers in the 230s that are bigger than 232. So case 3, we start with a 2, then a 3. This is a 2, this is a 3. Got to practice my squiggle brackets. 1 choice, 1 choice. How many choices do I have for the last digit? What are they? List them for me. I can't use 3's already gone. And this is why I want you to list them, because you will be tempted to write 3, 4, and 5 there. But we've already used up the 3. So that's why it's really important underneath our spaces to give a brief explanation of what it is, because you'll realize, oh, I've already used up my 3. I only have 2 choices left. 36 plus 6 plus 2, there's going to be 44 numbers that are possible. So to summarize everything we've done in permutations so far, right? We've had questions that can be done with spaces. For every decision you need to make, you make a space, and in every space, you write down how many choices you have. With the spaces, we've had some questions that have restrictions, where you have to deal with the restriction first. We looked at things with identical objects. That's like names that have the same letter repeated. And so you need to divide out that repetition when there's identical objects. We had grouping questions. Often students will get identical objects and grouping questions mixed up. Say you want to group something together, but the items are still different. You do your number of groups first, factorial, and then you do the permutations within each group separately. So we've had grouping questions. With the grouping questions and with the restrictions, I introduced you to the NOT strategy, where sometimes it's easier to count the bad ones and subtract them from all than it is to count something directly. And then today, we looked at there are times you can't count things all at once, especially if you have restrictions overlapping or numbers greater than, and then you need to use cases. As you go through your homework questions, and what we're going to do for the rest of today is do a bunch of practice, you have some questions that use 3 of these strategies. Some of them that use 2 of the strategies. Some that only need 1 strategy to figure it out. And so in each question, you're going to have to read it and problem solve which strategies make sense here, what kind of permutation question is it.